All right, welcome. I wanted to do a quick stream today. I have dinner coming up pretty soon, so I just wanted to keep this to an hour, but I wanted to also record the stuff that I did last night when I was not going to do to work on this anymore, but I ended up finding the problem that was causing us problems last time. So where I left off, the board has been built, done some rework to things. The CPU was running code at the end of the last stream, and but it was unstable, and it would run, and you could type for a little bit, and it would echo the characters, and then it would stop echoing, and a couple seconds later it would reboot and print the welcome message again. So it's running code. It was running code, but it wasn't running code properly, and I was unsure of what was going on, what was causing the problem. Previously, when I powered it on, it would not work. It would not start. It would not print anything. And then I would the JTAG was connected for the CPLD, so I unplugged that, and then it would work, and then it would do the reboot thing again. And I was playing around and touching the board and stuff, looking for any hotspots or anything that might change behavior if I touched the board, and touching around here and these jumpers especially was causing it to reset and go like this. It would sometimes print only part of the message and then reboot, and then print another part of the message and reboot, and so it wasn't even it was weird. It was weird. It was doing the thing. This was causing it to do the thing. But as I tried to isolate, was it a particular jumper? Was it a particular spot? It just wasn't being very reproducible. And other places I could hold this capacitor, and that was also causing it to become stable, which is really weird. So even pressing here, I wasn't touching anything electrical, and that was causing it to change behavior instead of sitting there being dead, not executing code, or occasionally doing the restart. So I took a look at the schematic, and so I took a look at the schematic for what's in this area. Pressing on these chips was causing it. One thing it could be, of course, is a poor solder joint or something. I inspected the solder joints, they all looked fine. Could still be a problem there, so I was poking around, looking at things, and I just happened to notice that the reset line, the reset input was going over to here. And I was looking at the schematic. Okay, let's pull up the schematic. For the reset circuit, and this is the normal reset circuit that I had. It's okay, halt and reset, right? So that's where, so there's the one reset, there's the halt, but that's those two inverter gates. So what was this other one going here? And noticed finally that I added this extra reset. So this is VSys reset is coming from the VMEbus, And if you would look at the card here, it's not plugged into the VMEbus. We don't even have the connector up. So that input from the bus is just floating. This input here is floating, so there's nothing in here, but if that accidentally triggers for some reason, it will reset the chip. So that explains our problem. So what I did was I just took a resistor here. This is just a 10K resistor. And I had it, if I can see the trace, it was that one. So having that pulled up to 5 volts was fixing the problem. I was able to run code, I could type in all sorts of things, but then I ran into another issue where it seemed like I would type a command into the monitor. I'll show you that in a sec. But I was typing in things, and there, like it was either saying unknown command or just not doing anything, as if I had just pressed enter without it actually typing in anything. So we'll get to that problem in a sec. But first, let's just make sure that we're back to where we were yesterday. Or like where I was last night without, off stream. But yeah. Okay, I need to connect here. We don't have power yet. This is a little annoying. Okay, I think that's all right. Should be able to connect here. Okay, and press the reset button. Welcome. I guess that is not really that clear. Can I make it a little bigger? And we can type. Well, that command didn't do anything, but this is kind of indicative of the problem. So normally I would be able to say help. It would give me a list of help information. But it's saying unknown command. So clearly there's still something wrong. And I also know what that problem is. I was looking at the logic for the CPLD last night, and I saw a mistake. So we'll dig into that next. We are running code though. We're most of the way there. Hopefully just a little more, and we will be able to actually run the monitor flawlessly, more or less. And then I might take some time to put the connector on or debug some of the VME stuff if we can, and then put the connector on. And then we'll go from there. So, I guess just digging into this problem. This is the behavior that I was seeing, and there's something that jumps out to me very clearly about what is going on here. If I do a single character, or 2 characters, or 3 characters, it does not say anything. It does not say unknown command, it just does nothing. And I know that with the program that's in the ROM right now, the only thing that would make this happen normally is if you press enter. So that shouldn't say unknown command. It just goes to the next line. But when I type 1, 2, or 3 characters, it does that same thing. And if I do 4 characters, I get unknown command. So that's telling me that there's a problem with recording the input that is coming in. It's clearly not saving the characters properly. And obviously it didn't respond to the help input. So it's not whatever it read in is definitely not right. And so what I would expect, what I would suspect is that there's something wrong with the way that the RAM is being controlled, because it's the RAM is going to be good. The RAM circuit, the way most of it is designed, is very similar to previous ones that I've done, previous boards that I've done. But the one thing that really is different about this board is that it's using a CPLD, and that logic is untested. I did not even test the RAM specific selects. I only tested whether the general RAM select was working, but not the individual byte RAMs. So I think there's something wrong there. I took a look at the code. There's something very obviously wrong with it. We have a case of the wrong logic. The logic isn't inverted when it should be. So one thing I'm kind of curious now about, I want to test before I actually get to that, is if it's only like saving every 4th letter, or if you only typed 4 letters, it's only saving one of them. Would I be able to get the help message if I did H 4 times, E 4 times, L 4 times, and P 4 times? No. Well, okay. I don't even know if it's like saving the right thing. It could just be completely not saving anything. So let's switch to the logic here. I will put that into focus. So looking at the logic, local peripherals is our RAM select here, and RAM DS, which is our data strobe, is all zeros. This so what's the it's if the size is 0, 1, then we are reading 1 byte, and we're reading the high byte. So let's look at the schematic. Memory. Yeah, so the upper part of the data bus, which remember is going to be our offset 0, because we're in a big endian architecture here. So our upper byte is being controlled by DS3, which is our high. So our most significant bit out of those 4 DS bits. The lowest, the least significant, DS0, is the low byte of this other RAM chip. So that's our D0 through D7. So that's the low byte. That's going to be at offset 3, not at offset 0, because again, big endian architecture. So looking back at our logic here, this is saying if the size is 1, so 1 byte, then only set the upper data strobe select line. So the upper byte, which is the upper part of the data bus, will be active, and the rest of it will not be active. So this is indeed inverted. So we'll just invert them. Make those 1. That one will be 0. Those will be 1. These two will be 0. These two will be 1. These will be 0. That'll be 1. Those will be all zeros, and our default state doesn't really matter. It'll be all zeros. So when it is 0, it means it's active. When it is 1, it's not active. So I'm hoping that's it. I'm hoping that's the problem. I'm hoping this will fix everything. And let's see if it even compiles. Okay, it does compile. All right. Switching back to the desk here. Let's get our programmer out here and hook this up. We are powering the board still. I hope this is all right. I mean, there's not. Yeah. I suppose I should technically hold like the reset button or something while we're programming this, but I'm pretty sloppy with these things, to be honest. Whatever. If it breaks, whatever. And then I get really sad when it breaks. Alright, let's try holding the reset just because. And I think that is everything. Give it a run. It is programming it. Finished successfully. And it's not running. Well, that's disappointing. I guess that means we gotta dig into this a little more. I have another probe here as well, so the other probe was acting up a little bit. I have used it many times. This probe is my lesser used probe, so hopefully it acts a little better. So I want to first just see whether it's running any code. So we should see the address strobe. Oh, look at that. All right, so it is running things. power cycle. Just eliminate that as a possibility. We still are not running, or we still are not seeing any output here. Reset's not doing anything. But it's running code. When things should be simple there, they don't go simply. All right, let's look at some that's the upper one. DS is the 5th from the top. So that's our address strobe. We're definitely having address strobe. 1, 2, 3. But we're not seeing one, two, three. We're not seeing anything on the pins that control the byte. It could mostly be running from ROM at the moment. We're still not seeing anything here. We are sending characters. So let's just take a look at this. That's kind of weird. This is a probe issue, I think. One, 2, 3, 4, 5. And our pull-up oh, dicks. Our pull-up resistor has fallen off just as I get the pin on. That's that. God damn it. This is fucking annoying. Maybe I should just put the connector on. But I like, yeah, I don't want to, in the sense that like it's potentially easier to do something sometimes, but harder to do some other things some other times. That should be it. Motherfucker. I would kind of expect that to be actuating. Or sorry, no, that's the... I'm on the wrong pin even. That would be our DS1. What I actually want is our DS3, which is the second chip there. Jesus Christ, I can't see a goddamn thing. My eyes are terrible. 1, 2, 3, 4, 5. So what I'm trying to see is if typing in the console, not in that, typing in the console causes anything. Where is our RAM select is 6, which is that pin. No idea what I did there. But I'm trying to do that, and I see that it is not responding at all. Yeah, that is just not showing anything. Let's go back. Okay, power's on. We've got a dress strobe. Oh, that would fucking do it. Yeah, my trigger's too high. Okay. Single step. There we go. Okay. So I'm on AES. I did a single trigger, and we are seeing stuff. So our trigger is right. Now let's go back. I want to look at this pin, if I can get on it. So single we do get some activity at the start and then nothing, right? If we type, we see the LED flickering. It's probably not very obvious, but this LED is flickering. We're not seeing anything here, so it is not actually asserting the signal like RAM cell. RAM cell is not even being asserted, let alone the bytes that we are looking at. Oh right, our stupid thing has fallen off. So I never know if it's actually in reset again. I don't want to solder a pull up on this because when it's connected to the bus, it'll be pulled up by the bus. I don't want a conflict on the bus, so I'm putting up with it for now. But I'm probably going to quickly cut my losses here because like I say, I don't want to be here for a long time. So I might just get into soldering and get this connector on. But this is really annoying because it was working. It was almost working, and it is now not working. It's possible that I just have this wrong, but let's go back to what I had before. My makefile is not set up correctly, so I need to just make a change so that that works. And yeah, I may have broken something else because I was doing some offline changes to the logic. I won't hold reset. I will just run this. Finished successfully. Back to here. And it's working again. Okay, so that did actually break something. Let's pull up the manual. Signal description. So 00 is supposed to be a long word, so I do believe I had the right interpretation there. Now that it's working again, let's take a look and see if we see activity on those pins. Single. There we go. So typing is giving some actuation. It's wrong, like it's the wrong direction. We should have the inverse of that. It should be always high and going low. So let's just do that again. So why is doing it the inverse way not working? And why is this way working? I'm so confused. Like it's working, but it's not working properly. I mean, it should work if this is reg and this is not reg, right? I guess other things like the request stuff. Serial ACK, which we don't really use anyways. Everything else is reg, except for this one. I don't think that's going to cause our problem. If request RAM is active, so we're accessing the RAM, and DS is active, then we look at the size, and then we write the bit. Oh, we have a complement here at the start, so it's that. Sorry, it should be that. And then we're shifting it by the address, yeah. And then we're inverting that. So what I originally had was this. Maybe actually that is the only change we need, as in always keep them high. And then, like, yeah, so it's kind of weird logic. Oh yeah. Now that I think about it a little more, I understand why I was doing it this way, as confusing as it is. So the idea here is that you have the address. The size determines the size of the operation that you're doing, and the address. This is the lower 2 bits of the address bus. Are used to determine what byte you're accessing. So if you're accessing you want to do a 1 byte operation, but you want to read the second byte, then you want the CPU is going to expect that second byte to be always placed onto address pins D16 through D24. So that is, because that is your second byte. I wonder if the manual shows it better than I can explain it. Yeah, this table here. So, the bytes labeled as N and previous are only required for they can be interpreted as don't care for non-cacheable RAID cycles. So it's the OP values that are what you want. If you're reading 1 byte and you're reading the 0th offset byte, your size is going to be 1, your address bits are going to be 0, 0, and your byte is going to appear on the upper part of the address bus, or the data bus, which is it's the highest byte. It would be DS3. But if you're reading like the 3rd byte, for example, or the 4th byte, I guess, your offset, your address is 1, 1. You want it to appear on D0 through D7. So in that case, we would want to, like, RAM select would be low, and then DS would be DS0 would be active in this case. DS3 would be active in this case. So going back to the logic here, we're shifting it by the address. So we want DS3 to be active, and then we shift it by the address. So if that was 3, we would shift it 3, which would make DS1 be active. But in the process of shifting, there's going to be zeros. So our number, as a result here, we would start with that, and then we would shift it by 3, and we would end up with that, right? So these 3 zeros that are added here are actually not the 3 zeros on the other side. They're brand new zeros that are being inserted into the number. And because we're always going to get zeros there, we can't make that 1 easily in another way with Verilog. So if we just do it inverted like we're doing, then we can complement the bits and we'll end up with what we want. But that means that our resting state must be all 1s and not all 0s. Because otherwise our resting state is going to be all bytes are active, and therefore all memory is going to be erased constantly, which is not what we want. And then this default case should technically never be run because we've only got four bits, 4 combinations that we could do, but it's kind of just there for completeness. So we'll compile this. We'll write this. Verify it. Was successful. Reset. It's running. Yes! 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 It's working! it's executing from PC address 78. So that's in the lower part. That is executing code from the ROM. All right. If I launch another window here, load, load it up in. Oh, the load script, right? Load. Okay. So, we're supposed to be transferring data over serial, and that did not work as I would have hoped it would. Did not see what happened there. Can we scroll up? Do we have any hints? Fatal error. During boot. Okay, so it loaded it successfully and then it didn't run. Alright, so our binary might not be very, might not actually be working. Reset. Is this gonna work? Nope. Okay. Alright, so clearly something is not working correctly. I want to move this to that screen. And is that gonna do anything? So that's the data that it should be sending. It seems still kind of big. Yeah, it's kind of the same size no matter what. Oh, we're doing that. I don't think this is going to help us necessarily, but you could give it another try. So loading this. Nope, still not working. All right. So if we just take that out, this is the actual thing that is going to be sent. It's just for information. It's sending. Oh, I don't have the. I don't know if flow control is working. The first 4 bytes are hex number in ASCII of the size, the number of bytes, or the number of words, I think it is technically, to transfer, and then the rest of it is the data. So it's going to transfer just like over serial. It does the load command. The load command, once that actually is executed on the monitor end, it then stops echoing characters, and then it's supposed to read the data in. It doesn't have a problem with the reading. If flow control was a problem, then it would not get to the boot. Where is it here? So here it executes the boot afterwards, which is going to jump to ROM or to RAM. I mean, it's supposed to jump to. I mean, that's wrong. Okay, so that's wrong. We've taken out the boot instruction. Let's reset it again. Let's transfer this image. Where are we here? Load is complete. So that should be our RAM, and that looks right. That looks correct. That should be our actual start address. Right here. So if I jump specifically, or sorry, that's the wrong thing, isn't it? That's not going to work. Unknown command. Boot. That. So that should do the jump. That's all the boot does. It's really jump, but yeah. All right, so that's still not working. It does print the welcome, and then it has a fatal error. Oh, actually, you know what? It prints the welcome message. It prints two new lines, like new line and the new line, and then it prints the null character. So that means that it is not properly detecting the end of the string, and then it's printing garbage. Like it's printing not fatal error with SP and then an actual stack pointer value in hex. It's printing %x. So that means that what it's actually printing is our strings. So it's printing the next string, because that is literally the format string being sent to printf, not the result of sending that string to printf. So, our problem here is probably related to well, I mean, it could even be a compilation issue. But it could also be an optimization issue. I've encountered a similar problem to this before. It's a little disappointing, because what I really just wanted was to be able to just do some things. It's getting to this statement, it's printing the message, but it's just continuing to print the message. Serial loop would have that as well, but we could just remove that, try that. So let's reset that. Let's do a reset so our ROM is still working. Make a new copy. Well, actually, we could delete that. send it, and we did a thing. We didn't see that we did a thing, but we did a thing. The thing that we did was writing a byte. Or actually, no, we didn't even write a byte. We did not complete this code. So that should have written a byte. Not sure if this is going to be observable. That's an interesting pattern on the scope. It's just garbage, but like, it looks neat. What was I doing? I was looking for the address strobe pin. Why am I not seeing it? It should be VAS. VAS, here. 18. Ground on either side, which is more of a guard because the AS pin is like really important on the VMEbus. Okay, we'll go auto. Oh yeah, we wouldn't see anything anyways. Goddamn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that should be our AS pin. If we reset, the memory should still be correct. Single, oh, I guess. Rising. I have a feeling I'm not going to catch anything, but yeah, did not catch anything. I mean, if we didn't catch the rising edge, we're not going to catch the falling edge, right? Yeah. Well, I'm going to say that our RAM is working fine and that RAM select logic is correct. The code that is being compiled is... I haven't compiled a ROM, and I had the repository like kind of in a mess from some other stuff, so it might just be that it's still... that the image is just not compiling correctly, which is why we're getting that that issue with it not finding the null terminating character. Or it could be that our we have something else going on, and without a... I mean, we could... there's ways to make it work. Well, no, because like the ROM is working. The ROM is working when it's this ROM. When we execute from this ROM, it has no problem. We find the end of strings, no problem. So yeah, I am inclined to blame the current configuration of the code and the shit. So I am going to go ahead and enable, or see about enabling, the VME stuff. And we might have all sorts of issues that come up as a result of this. But we'll see how we manage. Don't know about that. We have the interrupt stuff disabled as well. That should be fine. I could test that later. I really just switched that out, and yeah, we have problems. IAC. VME IAC is unconnected. Oh. Alright, IAC is fixed. We just have the situation with the DTAC. So this is bypassing the thing. No idea if this is going to work. It could totally mess everything up, but let's go for it anyways. So for testing, I had a different set of logic. I had logic... Before I forget, I should just touch the board and see what's going on here. I'm just feeling for like any burning spots to see if the chips are heating up again, but it seems all right. Get our little jumper in there. Just annoying. Oh, that's maybe not the best. That's maybe not the best. It was pulling like 500 and something milliamps when it was previously only pulling 300. So Like it was maybe going to 400, so that's 150 milliamps extra of something going on, which is probably a logic problem, a logic failure of some kind, or conflict of some kind. I don't even know if it booted. It maybe did not. Yeah, see, that's not running. Okay, that was great. Yeah, let's do one change at a time instead of doing all of them at once. Alright. Back up a little bit. Oh, I had thrown this in. I mean, it didn't give an error, so I'll just leave it. Maybe that's gonna be harder than I thought. I just want to quickly like figure out what's going on though. I'd like to see if it was related to the interrupts or not. That's not working. Oh, because I didn't also comment, uncomment this code. Comment. Okay, that compiled. Do I want to remove the serial port? I think it was the serial chip that was overheating. Go quick, go quick, go quick. Oh, there we go. It went down to 300. Oh, that's nice. Okay, when it's programming, it's fine. It's just when it was actually running, when the logic was running, it was doing the wrong things that we don't want it to do, which could have damaged things. And it is still doing the thing. Okay, let's now power it on. So it's not related to the interrupts, but that also means that we could probably enable the interrupts. So if we do get the current rating on screen so you can see what I'm complaining about. Oh, that's great. It's not great. I'm lying. Alright. This should just be back to what we were at before. Okay. Power on. Rating our shticks. Was not paying attention. Something is very weird. It shouldn't be doing that. It should not be doing that. And I didn't, like, save a thing. I wonder if I have damaged something. Also, this stupid fucking thing keeps falling out. What a piss off. We had it running and now we have it not running. And it's not running. It's not doing anything. We are worse off than we were. Let's quickly just see if it's like running any code. Nope. Well, we may have broken something. I'll try taking this serial chip out. And we're getting 420. It's a little more reasonable. But we are still not running the CPU, so oh, let's just like check that it's not that. Yeah, I don't know why it is not working anymore. Well, I did want to solder some things on. I do also need to order dinner. One step forward, two steps back. Well, I was not expecting to stream tonight, but maybe I will come come back on briefly and solder things once I've had a chance to play around with the logic or something a bit, because yeah. Alright, well, thanks for joining. If you did, I don't think anybody did actually join this one. Thanks for joining. I will maybe be back in an hour or two. We'll see. Yeah. Bye.